Welcome to the Future of Structures podcast, where we talk to the experts who are evolving our buildings for tomorrow. And here is your host, Adam Jones.
Today we are speaking with Professor Jay Sanjayan. He is the Director of Swinburne Centre for Sustainable Infrastructure and he's Professor of Concrete Structures. So his current projects include 3D printing of concrete, low carbon concretes, geopolymer concretes, and use of phase change materials in construction, and monitoring the performance of geopolymer concrete in the field. So this is one of my favourite interviews I've had so far. Might be a little bit biased as I'm a structural engineer, but we talk about topics like how 3D printing and robotics has the ability to disrupt the construction industry. This isn't really talked about in most circles, but on the horizon, this is inevitable. These technologies are coming, and the automation that it brings could cause a lot of disruption. Also, what are the best solutions to replacing Portland cement for more sustainable products? Obviously, we need to get to zero emissions by 2050. Portland cement is already 8% of the world's emissions, so Jay has some good answers for that. Do we go down the geopolymers, or do we talk about supplementary cementitious materials? And also all the innovation that is on the horizon for construction, and more specifically concrete. I hope you guys enjoyed this interview as much as I did, and without any further ado, here is Jay.
I've been working with concrete as a material for building structures for about 30 years now, since I finished my PhD in 1988 at Monash. I've been working there. I worked at Monash for 20 years, looked at concrete as a structural materials. But about 20 years ago, I got interested in geopolymer concrete. So, and we've been looking at geopolymer concrete as an alternative to normal Portland cement concrete. So when we started in 1997, not many people were interested in geopolymer concrete. The sustainability issue of concrete was only just starting to surface. As you may know, Portland cement emits, it's about 7% of the global carbon emissions contributed by Portland cement. But as you know, the renewable energy, solar energy and so on, they are targeting to reduce the carbon emissions worldwide. So in another 30-40 years, the carbon emissions from fossil fuels will come down. And if the cement production goes up the same way as we are, nearly half the emissions going to be coming from cement industry. So that's going to put a lot of pressure in cement industry. Right now we are 90+% of carbon emissions coming from fossil fuels, only less than 10% is from cement. So we are not under high pressure. But so the pressure on cement industry has been growing. So so when we started, it was kind of very small. Now there's a lot more people are talking about that. So last 20 years I've been focusing on that kind of research, and we have made a significant progress, but I think there's more is going to happen.
Yeah. So geopolymers are made up of, so what raw materials are geopolymers made up of?
Yeah, geopolymer uses fly ash mainly, or slag. They both are industrial byproducts from other industries like coal power stations. We have 14 million tons of fly ash coming out of Australia every year. And our entire cement consumption is only about 10 million.
Okay. Wow. So does it need the slag as well, or can it just be fly ash only? Yeah,
there are many different formulations for geopolymer. Some uses slag as part, but some uses entirely fly ash. It depends on the application and whether you need. You can accommodate high temperature curing. Around 60 degrees, or you don't want it. So that depends.
Cool. Yeah. And so with your research, what kind of properties are you getting with Geopolymer, and can it compete with Portland cement with properties like strength?
Yeah, I mean, strength is the first thing. There's no issues with strength. We can get up to 60, 70 megapascal. The main issues are depending on the curing temperature, we might have some creep issues and so on. But we're trying to target areas where conventional Portland cement are struggling to meet the demand, like acid resistance in sewer pipes. We have many kilometers of sewer pipes deteriorating under acid sewer attack, whereas Geopolymer has better acid resistance. So there's a company now making Geopolymer pipes for sewers. And sulfate resistant underground, where we have sulfate attack for normal Portland cement concrete. Geopolymer has better resistance. So it's much better to target areas where there's a better need other than carbon emission. I think one thing I realized last 20 years working in this field, people don't care about carbon emissions. So it has to be another reason, technological reason to use it.
Yeah.
It's the same way Portland cement, when it was first invented by John Simiatin, he was the first civil engineer, it was used to build a lighthouse. Because they built with timber, it collapsed, rotten in the seawater. And then they built with steel and it was corroded. Then they were looking for a material that can stand. So it wasn't because it was cheap, Portland cement was cheap or anything. It was to satisfy a need. So we need to look for areas where this Geopolymer concrete can satisfy a need that other materials can't.
Yeah. And then hopefully eventually it might have more mainstream uses.
That's right.
In high-rise buildings and so forth.
Yeah.
So you've got the kind of fly ash or slag or materials like this, but can you tell us a little bit about the activator or
Yeah. We use activators like sodium hydroxide, sodium silicate. I think that is the expensive part. We try and use as little as possible, so the formulations has to develop. Typically about 8% of the weight of the fly ash or slag, that's the main binder, is the activator.
Okay.
So that's the costly part, and that also has the carbon emission part, because we assume the fly ash and slag are produced by another industry, so there's no carbon emission, they want to throw it away.
Yeah. So it's got some kind of embodied energy in this activator, but it's still much, much better than normal Portland cement? Yeah.
I mean, it has there have been papers published about showing about 80 to 90% reduction in carbon emissions.
80 to 90%, wow.
Yeah.
So do you think geopolymers are a potentially a better solution long term than just replacing cement, a smaller portion of cement, as opposed to entirely?
I think they both are valuable ways. We should be replacing Portland cement anyway with supplementary cementitious materials, because it gives us better properties, more durability, and reduced carbon emissions and so on. So at the moment we do use about 2-3 million tons of supplementary cementitious in Australia. Out of the 11 million cement, I think 2-3 is 2 to 3 million is supplementary cementitious material. So we should keep going with that anyway. Yeah, but try and increase that. It would be the better way.
Gotcha.
Yeah.
Nice. And with the fly ash, I think, did you say it was 11 million tonnes per year?
14 million is available in Australia.
And is that from coal mines?
Yeah, it's coal power stations. So we are using a lot of coal power, for electricity. But we have to remember the last 100 odd years we have been using fly ash.
Huge
All
stockpile.
that is stored in the ground. So even if all the power stations stop now and use solar panels, we will have enough fly ash for another 100 years.
Oh, wow. Nice. So that
Yeah.
even if it's in the ground, it's really easily...
It's not easily. We need to do research to see how to use the wet ash, because it's already, once it's in the ground, it's wet. So it need to be dried and used. So there's an extra process involved.
Yeah.
But you know, it's all, at the moment we have very nice dry fly ash coming out of the power stations. So nobody bothered to use the wet one.
Yeah. And have you done much work with, say, replacing... is there any solutions for steel? So that's another thing that has huge emissions, is like the reinforcement steel. Do you know much about any alternative materials there?
Yeah, alternative to steels are been, you know, carbon fiber reinforcement, glass fiber rods, plastic fibers. They're all been around. And the research, I think the current problem is the stiffness. See, the steel has an elastic modulus of 200,000 megapascal. None of them can match it. Even carbon fiber, a very good strength, but not the elastic modulus. So if they don't have sufficient elastic modulus, they cannot attract the stress in the composite, you know, concrete and steel.
Yeah.
Steel is about 7 times stiffer than concrete, so you only need 7 times less steel can attract the same amount of stress because it's stiffer.
Gotcha.
Yeah.
Awesome.
Yeah.
So if we're going to target some of the Portland cement market, do you think you mentioned some applications when it's very corrosive. Do you think it's going to go through the infrastructure market or the buildings market first predominantly?
Both. I mean, you look at these low risk applications like payments, which is infrastructure. It's an ideal way of starting out. We already have a lot of geopolymer pavements in Melbourne. Melbourne is actually leading the world.
Oh, wow.
Actually, Australia.
Yep.
We have an airport that's been built with using geopolymer. In Melbourne, we have something like 50 or 60 installations. And we have 2 or 3 companies. There's one company making geopolymer burial crypts. So I can, when I die, I'll want to be in geopolymer burial crypt. And then there's another company making pipes. So
yeah, nice.
There's no other everybody working in geopolymer. There's a lot of researchers worldwide. They come to Australia to look at these things.
An airport, that's a pretty big application for it. Is there any? I heard somewhere there's a problem with, or can be a problem with the getting burns and this kind of stuff. Is it easy to work with, or do you need extra protection as well?
Yeah, they, even with normal cement, we can get burned. You got to be careful. But if you have liquid activator, and it has a very high pH, that is it needs to be not manually handled. It should be. So those things, when they built the airport and other construction, they went through the OHS and issues and work it out. I mean, it's not the current. We have so much technology out there. We can do these things without manually handling.
Cool.
We just pumped. We just stored in a silo, and it's pumped and it's mixed. The other solution is powder activator. So the powder activator is mixed with fly ash and slag. So we call it 1 part geopolymer. So just add water.
Oh, nice.
So in that case, there's no OH&H issues.
Cool. Another really interesting part of your research is in 3D printing of concrete.
Yeah.
When did you first come across 3D printing, and what did it look like?
It's about 3 years ago. It was about 6 or 7 years ago. Someone was talking about it, and I thought, this is, what can I do?
Crazy.
But then I kind of left it. But then about 3 years ago, I saw some YouTube videos. I think, see, this is a new technology, and it's instead of the traditional journal publication. If you look at journal publications, there's about 5 journal publications on 3D printing. You go to YouTube, there's huge number of things. So you can see this new research area is actually using a new medium. If you're not in YouTube talking about 3D printing, you are nobody. So 3D printing presence is in YouTube and social and internet and so on. But
podcasts now.
Yeah, podcasts now. Yeah. So the new research is actually in the new medium.
Yeah.
And it's very interesting. But that's where I first come across.
Oh wow.
Yeah.
Awesome. So how does it actually work? It's very hard to visualize, because I personally haven't seen a 3D printer work. Maybe seen a few YouTube channels, YouTube videos,
Yeah.
but yeah, how does it go?
There are different techniques. There's one is using the extrusion technique. So you go layer by layer, just add one layer, but you extrude the concrete and place it one on top of the other, like that. That is similar to most of the 3D printing, plastic printing you can buy from Bunnings and Officeworks and so on. So I think that's another reason people start to see these commercial 3D printers using plastics, and they say, oh, why can't we do it with concrete? So that's how I think a lot of interest in the last couple of years. I think I've been into different countries, and they're all, everybody's now working in 3D printing.
Yeah.
There is a lot of interest. So that is the layer by layer printing.
So it's like a robotic arm that's putting layer by layer.
Yeah, it's more like a CNC machine,
Oh.
and then it prints layer by layer. It's a gantry, or you can use a robotic arms as well. And then the other method is powder based, where you have a powder bed, and then you could be cement and mix with sand and aggregate, and then you print a layer of you inkjet. Ink is water, and you print like you would print in a normal HP printer.
Oh yeah.
And then you add another layer of sand and cement mix, and then you use the ink, which is water, print again, and then at the end you just have to lift the hardened part out of the sand cement bed, and then you recycle the rest of the thing. That is a lot more accurate. You can make very intricate shapes, very nice, but the problem is you have to recycle a huge amount of material.
It's a good point with the intricate shape. So do you think it might eventually get to the point where if you do a structural analysis and there's some part of the concrete that's not necessary, say if you look at a footing, and you might have a strut and tie model, so there's so much concrete that's actually not even doing anything.
That's right, yeah.
So do you think 3D printing might eliminate all the unnecessary concrete?
Yeah, so that's one area where it can be really useful. I mean, if you look at I'm not sure whether your listeners familiar with topology optimization, structural topology optimization, where you give the forces to the finite element computer program, and it will try out different shapes and come out with a shape that is the most optimum for that force. And people have been working in this field for 20 years or so, and always they've been told that this is not practical.
Yeah.
It's nice theoretical work, but it's not.
I can imagine if a structural engineer
Yeah.
shows one of those models maybe to a builder, then the builder will, swear back at them.
Yeah.
But then a printer is never going to get angry.
That's
something
right.
like-
The printer can print any shape. So, like buildings like Opera House, it's so difficult to build. I mean, they had to build a timber structure, a timber Opera House first, and then pour the concrete, and then when the concrete casts, they can demolish the timber of timber formwork and throw it away. So there's so much wastage of construction industry is in the formwork. In Sydney, some people did some calculations to show that 60% of the cost of concrete construction is formwork.
Oh, wow.
Yeah, and a significant part of construction wastage is formwork, because you build something, you have to build twice. First, you have to build with timber, then you have to pour the concrete and then throw away the timber. So with 3D printing, we can build any shape, and whether you build a rectilinear shape or an odd shape, it's going to cost the same. So it gives a lot of freedom for architects.
Cool.
Yeah.
So before you was with Geopolymers, you were saying there were certain early applications that it might be able to penetrate, or a market might be able to penetrate for Geopolymers. What do you think it is for 3D printers, like unique kind of applications that it might get in first?
I think the market for 3D printers now is the odd shapes. There's actually a sculpture in Docklands in Melbourne, and they have built with glass fiber reinforced concrete, which was 3D printed, part manual, part shaped by a robot. But when you try and build a big sculpture and something, right now that's the most economical way. So if you want to build odd shapes, structural components, this is the best way.
Cool.
Yeah.
I can imagine architects will love this as well.
Yeah.
They'll be able to do whatever
That's
they want, really.
Yeah.
So with the
it already has applications on bathroom, the glass fiber reinforced bathroom bases.
Yep.
They had to make mold, and every time there's a new mold, it just takes them about 2-3 months to make a mold. Now they 3D print it, so it's already being used in some industries.
Cool. So when they do it on site, do they need to bring the 3D printer, and is there limitations at the moment on how big the 3D printer can build, and if so, can they surpass these limitations, do you think?
This technology's on-site construction is very early. At the moment, the applications are all inside factories. There's a couple of the real on-site applications actually happening in China. There's the China State Corporation. There's a few companies. I've been to see some of the houses they built. And they are using a printer which is bigger than the building.
Oh, wow.
So that is the problem, because your gantry printer has to be bigger than the building so it can print it. However, there are concepts and ideas around where the printer can climb on top of the building. Is already built, like you do with the slip forming with your lift course. So once you do like that, then there's no limit.
Oh, wow.
Because you print it, and then the printer climbs on top of the already built and keep printing. So it can be a robot arm. and it can have a mechanism to go up on the already built structure.
Wow. Well, if this comes through, that'll be a robot arm that works on weekends, that works on night.
Yeah.
It doesn't take public holidays. It doesn't take sick days.
Yeah.
So
Yeah, we have now our powder-based printer at Swinburne. We just leave it at night and come back in the morning. It's finished printing. So,
unbelievable.
so during the daytime we set up all the powder and all these things, but nighttime it prints.
So do you think the rate of progress of this technology, is it moving pretty fast, or is it?
Yeah, I think it's going to be faster than we think.
Oh wow!
Yeah. Because of the amount of interest around the world. It's just in the within last year, I've seen so many people talking about it, and if so many people, researchers, industry, talking about it, it's going to happen, because it's not very difficult to explain to someone.
Yeah.
It's because they already know about 3D printer. They've seen it in small scale with plastic, and you say, how about building with concrete? They say, oh yeah. So it's easy to capture many people's imagination. So once a technology is, the hardest part is to capture people's imagination. Once it's there, and the efforts will be made and things will happen.
Yeah. And on the other side of the equation, so you've got advanced computations, so the finite element analysis with 3D printing. I saw a little while ago an architect using like an artificial intelligence to make really unique shapes, and so do you think it's going to be a point where other technologies like artificial intelligence are doing some of the design, and then the other new technologies, 3D printing, are coming together to make some really innovative buildings? That's
right. So the other areas like computationally developing what is beauty, and those areas are progressing, and the construction field has to grow to match, and then I think we will feed from each other.
Yeah.
I think it's all quite an exciting future.
Cool. Yeah.
Yeah.
Oh, never been a better time to be around, I think.
Yeah.
It's incredible. Do your areas of research in geopolymers and 3D printing, I see that you're doing some exciting research where they meet. So can you tell us how they, I guess, adapt?
Yeah, I think what we find when we start doing with concrete 3D printing, the conventional concrete is not really suitable for construction concrete 3D printing, because it doesn't, we can't make it, it has to be fluid when it's in the machine, and as soon as we extrude it, it has to be thixotropic, so it retains the shape. When the moment you stop vibrating, it retains the shape, and then it sets quickly on demand. So we need to manipulate the cement setting characteristic to suit the printing. And at the moment, with conventional Portland cement, people are adding heaps of retarders, overdosing with retarders, so they don't set when it's in the machine, when they're pumping, when they're extruding. But then when they're extruding, at the time they're heavily overdosed with accelerators, so as soon as it set, as soon as extruded, it set. So these high doses of retarders and accelerators, it's like taking a lot of drugs. It's not good for the concrete.
Yeah.
So because the conventional Portland cement is really optimized for the current construction method, where you mix the concrete in a concrete mix plant, you got 2-3 hours to transport it, and then somebody needs to compact it. So it is really, really optimized. And it has to comply with an Australian standard AS3972. It has very, very strict limitations of what is the setting time. So we want to make a cement for this application. It is not tailored for 3D printing.
Gotcha.
Whereas with geopolymer, we are actually making the cement from the beginning.
Yeah.
So we can make it to what we want. There's no cement factory to make the cement. The people who are mixing the cement, mixing the geopolymer, actually making the cement and making the concrete at the same time.
Yeah.
So we can tailor make whatever we want. I think that's where geopolymer comes. I think we can tailor it very easily.
Cool. So geopolymers might be the preferable cement. So not even worrying about carbon, it might be even just more preferable naturally.
You can see that already happening. We are using geopolymer cement because we have history and expertise. But the people new to 3D, new to geopolymer, also using geopolymer for 3D printing, like the group in Singapore and the Episco, the Russian group. They're all using geopolymer, so you can see that they must have found something valuable.
Yeah, wow. Yeah. That's so exciting. So 3D printing becomes really mainstream, then geopolymers naturally might do the same.
That's right, yeah. So it's the better fit for 3D printing.
Cool.
Yeah.
Awesome. Coming toward the end now, so what do you think will have the most or the biggest impact on the buildings industry in the future? And it could be anything.
The building industry, there's a McKinsey report published early this year. I don't know whether you're familiar with it, but they showed how the last 50 years the productivity in construction industry has been stagnant. Okay. And it's not that hard to imagine compared to manufacturing industry and the total economy. Every year about 4 or 5% productivity increase, whereas since 1995 is nothing. Productivity hasn't moved. And we can see, I mean, you look at construction 100 years ago, there's a guy pushing the wheelbarrow with the concrete, and it's the same in the construction industry now. So you look at the manufacturing industry, aerospace, shipbuilding, they're all robots, artificial intelligence, data sharing, all that technology is there. It's very easy for us to just take the technology and apply in construction industry, and that's going to be the biggest transformation, because we can. There are issues like in manufacturing. They'll be they're just dealing with kilos, but we are dealing with tons. So we are dealing with heavy things. So the technology needed to be adapted. They are dealing with nanometers, micrometers. For us, it's centimeters is very good. But we need to be price competitive. They can be expensive, but construction industry has to be cheap. So those technologies, we need to take it from there and apply in construction industry, but we need to adapt for the cost, the accuracy, and the weight, and so on. But that is, I think, is going to be the biggest transformation. We are just on the verge of a major transformation in construction industry. It's mainly automation, robotics, and computers. Not just computers, is sharing information, building information modeling. So where from the time you start thinking about building, from the design to construction to asset management, maintenance, and to end of life, entire thing is going to be captured in one building. BIM is a big thing. So within building information modeling and management, 3D printing and automation is all going to come as part of that. And I think many people already recognize this is the major impact that's going to happen.
Yeah. Wow.
Yeah.
How exciting.
Yeah.
I'm super excited to be in the industry. So thank you so much for coming on the show, Jay. That was amazing.
Okay, thanks, Adam.
Hey guys, Adam here. Just before you go, just one quick request. If you're enjoying the show, please leave a review. It helps our rating and ranking on iTunes, so more people can hear from the people who are making our cities better places for our future.